Why does your agent rerun the same tool when you ask a follow-up? Welcome to AI Agents in Depth, Episode 2, Context Engineering. You'll build a loop that remembers across turns and prove it green. Last episode, we built the thought-action observation loop. Today, we give it memory across turns. VS Code, open that image right in its own pane. Not a browser, not a PDF. It's a rendered page displayed like a photo. Boji lies AI Agents in Depth, Chapter 2. Context determines the agent's capability ceiling. That Chinese phrase is the book's original text. Same meaning exactly. Not model size. Not tools. The messages list accepts exactly 4 roles. Only 4. Let's draw them to make the structure concrete. Excalidraw is a drawing canvas baked into VS Code. You're looking at a pre-drawn diagram, 4 horizontal lanes. Gray, system. Blue, user. Green, assistant, the thought and action. Orange, tool, the observation. Turn 2 adds another blue-green-orange row. The gray row stays frozen at the top. Those 4 roles live in the code you already wrote. Let's find each one. Scan down from the top of Run Agent. System MSG is first, index 0, then user MSG. Inside the loop, the model's reply appends as assistant. The tool result appends as tool. 1 complete turn, 5 entries total in that list. The LLM has no persistent internal state between calls. Watch what that means in code. Look at the parameter. Fake LLM receives the full messages list, not just one message. The model can't remember across calls on its own, but passing the whole list gives it every prior turn. Memory lives in the list. We stub the brain so you watch the loop. Your turn. Press Ctrl-P now. Type agent and open the file. Find all 4 role strings. Spot system, user, assistant, tool in the code. 4 strings, the model's complete working memory. Real APIs attach a tool call ID to tool messages. Don't add it now. You won't need it until you swap in a real API. The SDK handles it for you then. Fake LLM, Pi is still open. Jump to the bottom, that's where it branches. No tool message in the list, it calls word count. Found one. Reads that result and returns final answer. The stub's already multi-turn ready. The bug isn't here. The bug's next door. Multi-turn needs no special server, just a longer list. Their messages equals system message, user message. Run agent rebuilds that list fresh on every call, so each call throws away every prior turn. Scroll to the inner loop now. Each React pass appends assistant reply, then tool result. Both go into messages before the next call. It checks final answer before action. Reacts exit. Don't append the tool result. Fake LLM gets the same list and loops. That context, append is the memory. React beat chain of thought by 34 points on ALF World. That's the loop you just read. Go ahead, try it. Two single-turn tests. Read both, they're your baseline. Next milestone, we add a second turn and prove the agent actually remembers. Time to build. One constant, then a function that keeps its message list alive across turns. There it is. System message set once before the loop. Each turn appends user, then assistant, then tool result. The list keeps growing, never resets. Before the fix, watch what happens when you hand the stub only the latest message. No history at all. No tool message in the list. The stub reissues action word count. It starts over from scratch. Pass only the new message, and all prior context vanishes. That's the discard bug. Now the fix. Turn 1 gets hello world foo, 3 words. Watch what turn 2 echoes. Turn 1 counted hello world foo, 3 words. Turn 2 asked, and now double check, which standalone would count as 4. But the stub saw the prior tool result in context and returned 3. No fresh word count, no redispatch. One more check. How many system messages end up in that list after 2 turns? Exactly 1 system message, at index 0. You set it once and reuse it every turn. Repeat it inside the loop, and you burn tokens. Real models may treat the repeat as an override. Your turn. This run feeds 1, 2, 3, 4, 5, as turn 1, 5 words. Predict what turn 2 echoes before pressing enter. Go ahead, run it. Turn 2 says 5 words. The count from turn 1 reads straight off the shared list. Different input, same principle. Append, never discard. It's the ideal multi-turn test vehicle. Deterministic means bugs show up in your code, not the model. 2EP1 tests live here already. We're not touching fake LLM. The new stub lives right in this file, so every failure traces back to your messages list. This stub intercepts double and reads prior context. Everything else delegates to fake LLM. Let exceptions propagate always. It reads the last tool result, multiplies by 2. No try except around that int. Call if the list's wrong. The test fails loudly, not silently. Turn 1 counted 2 words in hello world. Doubled, that's 4. Build that exact messages list, then ask double that. Five entries from turn 1, then turn 2. Tool result is 2, stub doubles to 4. Assert 4 in answer proves context was read, not ignored. All 3 tests, EP12 plus the new multi-turn one, must pass together. Three green dots. A single react turn is under 200 tokens. GPT-4's 128K window holds 600 plus turns before you'd need Chapter 2 compression strategies. For Chapter 2 strategies: KV cache, prompt engineering, agent skills, compression. KV cache saves attention results. Same prefix, no recomputation. Run it. Each test name appears, all green. Because you never reorder the prefix, the system message stays frozen at index 0. That's KV cache in action. You built it. System at index 0, then user, assistant, and tool appending across every turn, never reset. You proved the discard bug live. 2 pytest tests run green. Turn 2's answer reading turn 1's count. Chapter 2 names KV cache and compression for when the list grows long. That's next time. Pause here. Add a triple that third turn, update your stub to return 6, assert 6 in the answer. Quick quiz. What role holds the tool's return value? Role tool. What single line kills multi-turn memory? Resetting messages to an empty list between turns. Next up, Episode 3, Agent Memory and RAG. Follow so you don't miss it.